Okay, question 16. Which of the following is the interval of convergence for the series that goes from n equals 0 to infinity of x plus 2 to the n over 2 to the n? So whenever we're asked for an interval of convergence, that's a hint that we're going to need to use the ratio test. So that's one of the things that we have to keep in mind here. Now the other thing I want you to note is, if you take a look at this series, both the numerator and the denominator are being taken to the nth power. So what this means is that this is a geometric series. And what we know about geometric series is that the endpoints will always diverge. Now, that's kind of the case where the common ratio is equal to 1. And with a geometric series, it's always going to result in a divergent series. So right away, I can cross off B and D because they both have this less than or equal to option. So our answer is going to be A or C. Well, let's go ahead and do the ratio test to determine which one it is. So for the ratio test, we do the n plus 1 term divided by the nth term, which is the same as multiplying by the reciprocal. And then we can cancel some things out. So I can cancel out the 2 to the n. I can cancel out the x plus 2 to the n. And we're left with an x plus 2 over 2. And we're going to force that to be less than 1 to find the ratio or the interval of convergence. I'm also going to multiply by 2 here. And we'll end up getting x plus 2 is less than 2. The 2 becomes my radius. And this 2, the part of the x plus 2, that becomes my center. In fact, my center is going to be negative 2 because it's always x minus the center is less than the radius. So if the center is at negative 2 and the radius is 2, that means my interval of convergence goes from negative 2 minus 2, which is negative 4, up to 0, and we're not going to include the endpoint. So our correct answer is A.